Today I am going to discuss some ideas about tangents and perpendicular bisectors with relation to circle geometry. So in order to do this, we first of all need to define what the theorems are that I'm going to be looking at. And the first one we should be quite comfortable with, and that would be that a radius and a tangent meet at 90 degrees, so therefore a tangent lies perpendicular to a radius. This is important for when we think about gradients, as the tangent would be the negative reciprocal of the radius and vice versa. The second rule, which you may not be familiar with, is that a perpendicular bisector of any chord in the circle passes through the centre of the circle. This is really useful because if I have multiple chords and I find the bisector of both of them, I could find the centre of a circle by looking at the intersection points, as shown here. I just want to run through a quick example of how we can use one of those theorems. And the question that I'm asked is, a circle has an equation x subtract 3 squared plus y subtract 7 squared equals 100. Verify the point P, 11, 1, lies on C. So the first question is leading me into the type of circle that I want. So if I'm verifying a point is on the line, I'm just going to look at the left-hand side, and at P, my x must be equal to 11, and my y must be equal to 1. Therefore, 11 subtract 3 squared plus 1 subtract 7 squared must be equal to something. I know it needs to be 100. When I work this out, I get 8 squared plus negative 6 squared equals, well, 64. Add 36 does indeed equal 100. Therefore, P is on the circle. On the circle. And what do they define the circle as? C. That would be all I would need for my question 1. So make sure you've understood that, but all it is just some substitution. The next part is where I'm going to be thinking about my circle theorems that I looked at previously. Find an equation of the tangent to C at the point P and give your answer in the form of ax plus by plus c. So I've got quite a few things I need to do here. In order to find the equation of a tangent, I need to find the gradient of the tangent. In order to find the gradient of a tangent, I would need to find the gradient of a radius from my centre of my circle to this point P, which would be down here. So in order to find the gradient of a line between 2 points, we're going to use the difference in our y values over the difference in our x values. Looking at coordinates then, the difference in our y values is going to be 1 subtract 7, because the centre of my circle is 3, 7 from looking at this form. And my difference in my x values, well, that's going to be 11 subtract 3. Therefore, I'm going to get negative 6 over 8. So therefore, the gradient of my radius, such as subscript r, would be negative 3/4. So the gradient of my tangent must be positive 4/3. Now I've got the gradient of my tangent, I'm just going to use the standard formula for the gradient for the equation of a straight line, which is y subtract y1 equals m lots of x subtract x1. This is really good for when we have the gradient, which I do, and a point on the circle, which I do. Sorry, a point on the line, which I do. So therefore, substituting in, I get y subtract 1 equals 4/3 of x subtract 11. Just going to drag this across here. And then we can solve this in any different way you want to. I'm just going to multiply everything by 3, so I get 3y subtract 3 equals, and then I'm just going to expand 4x subtract 44. Taking everything across to one side because I need it in ax plus by plus c. That would give me 3y subtract 4x plus 41 equals 0. And that would be in the form that this question is requiring me to have. I'd like you to make a note of that, please. I'm going to go through another example of, again, a question now where we need to think about what we're given and how we can use it. A circle C has an equation, and I'm just going to write down my centre point straight away, which is 4, -4, and it's a radius of √10. I don't know if it's useful yet, but that's what I'm going to do. The line L is a tangent to a circle and has a gradient of -3. Find two possible equations for L, giving you answers in the form of y equals mx plus c. Okay, this is very different to a question we've had before, because before we were trying to find the gradients, whereas now I'm given that my gradient of my tangent line is equal to -3. So therefore, I could work out the gradient of my radius, which would be +1/3, but how can I use that to find these points? So let's imagine I have this circle, and that is at 4, -4, this centre point is. A third is going to look something like this. So what I actually need to do is I need to find the equation of this line, which has a gradient of a third and goes through the centre point, and find the intersection points with a circle to hopefully get those coordinates. So to do this, first of all, I'm going to think about my equation of my diameter here. Well, it's going to be y subtract my y value, which is -4, equals my gradient, which is a third, of x subtract my x value, which is 4. Multiplying through by 3, I'm going to get 3y plus 12 equals x subtract 4. And then I'm going to try and get this in the form of y equals mx plus c. So by doing that, I'm going to get y equals a third x, and it's going to be subtract 16 over 3, just by subtracting 12 and divided by 3. Okay, so now I've got the equation of this line, this diameter. What I want to do with this is I want to find the intersection points with this circle. This is something we've done quite often in class, where we just know what y is, so we substitute it in. So I want to try and solve x subtract 4 squared plus, well, no longer going to use y, I'm going to use all of this, which is a third x, subtract 16 over 3 plus 4 squared, and that's going to be equal to 10. So by solving this, by just using my calculator, I'm going to get two x coordinates. My x coordinates are going to be 1 and 5, 1 and 7, sorry. So therefore, my corresponding y coordinates for 1 is going to be -5, and my y coordinate for 7 is going to be -3. I would like you to do this expansion, and then using your calculator, you can solve the equation. So I would have coordinates 1, -5, and 7, -3. They would be the coordinates of my intersection points here. I want to find two possible equations for the line. Well, I was given the tangent gradient as -3. I now know a point, so for set A, let's just call this one A and B. For set A, it's going to be y subtract, well, it's -5, so y plus 5 equals my gradient, which was -3, lots of x subtract 1. So solving this, I'm going to get y equals -3x, and then +3 subtract 5 is going to be -2. So one equation would be y equals -3x subtract 2, and looking at set B, it would be y plus 3 equals -3 lots, and this time it's going to be x subtract 7, and again solving this, I'm going to get y equals -3x plus 18. So again, I want you to pause this and go through it if you're not sure of any step, and email me if there's anything that you need to go over a bit more. But the way we can think about all of these put together now, let me just make this a bit bigger so we can read it, is putting our circle into a system, and we want to basically find the equation of a circle. So the last part says find the equation of a circle. So I want to know the midpoint of a circle and the radius. Okay, so points P and Q, I think I'm going to need to draw a circle for this, so it doesn't need to be perfect. Shape, circle, just going to draw a circle here. So point P and Q, line of a circle with a centre C. So it's got a centre C as shown in the diagram. So I'm just going to draw the diagram of the system, what it should look like. I'm going to have a line going across here. So this is point P and Q. Let's just put them on. If it's got a coordinate -8, -2, that's going to be over here somewhere. And I've got another point Q, which is going to be 2, -6. Okay. So the points P and Q have these coordinates. M is the midpoint of the line segment PQ. So I need a segment or a chord going across, and M is going to be this midpoint. So let's call it here. The line L passes through points M and C. So this line L must be a perpendicular bisector if it goes through the midpoint and it goes through both. So it's a midpoint of these, so therefore they're going to be the same length, and it goes through the centre of a circle, so it must be a perpendicular bisector. Okay. I think now I've got enough information to answer this question, so I'm just going to shrink this a little bit. I'm going to drag this up just so we can see it. Okay. Find an equation for L. So I want to find an equation for this line. So to find the equation of a line, I need the gradient, and I also need the point of a line. So to find the point of a line, I'm just going to find the midpoint of P and Q. So midpoint is going to be equal to, well, -8 to 2 is going to be -3, and -2 to -6 is going to be -4. So the midpoint of my line, so this M, is -3, -4. And the gradient of the line, well, the gradient of PQ is going to be the gradient of this chord. So it's going to be my difference in my y values over the difference in my x values. So this is going to be -4 over 10, which simplifies to -2/5. So that would be the gradient of my chord. So working with these two now, to get the gradient of my line, it's going to be y sub +4 equals -2/5 of x plus 3. I'm not told what form I need my line in, so I'm just going to leave it like this, because that is an applicable and an appropriate form for the equation of a line. Part B says, given the y-coordinate of C is -9, show that the x-coordinate of C is -5. Okay, so I've got this. What I need to think about now is, how can I work out my x-coordinate? Well, I've got an equation here for the line L, which point C is on. So if I substitute in my y-coordinate into this equation, it should tell me the corresponding x-coordinate. So when y equals -9, -9 plus 4 equals -2/5 of x plus 3. So looking at trying to solve this, you could do the appropriate steps, but you would again verify that x must be equal to -5. So therefore my coordinate of my centre has to be equal to -5 and -9, which is really nice. So I've got my centre point now. Finding the equation of a circle, well, I need my centre point, which I've got, and I need my radius. Luckily, if I've got a centre point and I've got a point on the line, I can find out my radius. Well, my radius is going to be equal to the square root of the distances between my centre point and a point on the curve. So let's think about this point here, this point P. -5 to -8 is going to be a distance of 3, and -9 to -2 is going to be a difference of 7. So my radius is going to be the square root of 3 squared plus 7 squared. 9 add 49 is the square root of 58. So therefore my radius is equal to the square root of 58. I've got a centre point and I've got a radius, so now I can work out an equation of a circle. To do this, I'm going to get x plus 5 squared, add y plus 9 squared is going to be equal to my radius squared, which would just be 58. Okay, I appreciate that I have maybe spoken at length about why it is important to write a diagram, but really without a diagram in this question, I would have been struggling. What I would like you to do then is have a go at these two questions. Once you've had a go at them, I'm going to just briefly show you the answers, but make sure you're trying to verify your answers, and if you've made a mistake, or maybe you've got something different to me, please feel free to actually email me or message me, and I'll try and talk you through it. Okay, so pause the video now, have a go at these two questions. And for question 1, we should first of all work out the gradient of our radius from using the centre and point P, and that would give us our gradient of a tangent, using the equation of a line, solving it and rearranging it into the form that they give us. For question 2, it's slightly different. We first of all work out the gradient between the 2 points, A and B, and therefore we can then work out the gradient of the perpendicular line, which would be -2. We've got a midpoint, we can work out the equation of the bisector, and then we can substitute in the value of -1 to get the corresponding y value. We can find the radius in a very similar way to what we did in the previous question.